So now we're going to look at multiplying complex numbers. Now, the one thing you want to remember is that complex numbers are not real numbers. Okay. So they don't always follow the same rules that real numbers would follow. Okay, so for example, with real numbers, if you have square root of 4 times square root of 9, if you wanted, you could just go ahead and combine those. So that would give you square root of 4 times 9, which is square root of 36, which is 6. Or you could have just made it 2 times 3 there. Okay. So this wouldn't work for complex numbers. So if you did that for a complex number, so let's say if you have square root of negative 4 times square root of negative 9. If you brought them together to be square root of negative 4 times negative 9, which would be square root of 36, which is 6, which is false. Okay. With complex numbers, the negative can't just disappear. Okay, so you couldn't do that one. Now for complex numbers, if you did want to solve that one, I'll bring that up a little bit. If you did have square root of negative 4 times square root of negative 9, you'd make it I times square root of 4 times I times square root of 9. Okay, so that square root of negative 1 didn't just disappear. You actually just moved it out. Okay, which equals square root of 4 is 2, square root of 9 is 3, and you have times I times I. Okay, so this actually will give you 6 times I squared. When you're multiplying, that I squared will pop up quite a bit, and that's the real difference between just regular variables and imaginary numbers, is that I squared has a value. Okay, so if you remember, we know that I equals square root of negative 1, but if we square both sides, I squared equals negative 1. So this actually becomes 6 times negative 1, which is negative 6. Okay, so that's why they're treated a little bit differently. All right, any questions on that one? All right. Like I said, this is the one, this will pop up over and over and over when you're multiplying. All right, leave that up for a few more seconds.
So if I square is minus 1.
Yep, I squared would be negative
If
1.
it's I cube, it will be again plus 1.
Actually, that's a good question because and we're going to cover that, but with I to the third, that's just I squared times I. So that would be negative 1 times I, or just negative I. Yep, so we actually do cover that, I think, after division. So we'll cover all that. A good question. Yes?
So could that be used as like a false proof that 6 also equals negative 6?
No, because you're going by real number rules. If you were going by just real numbers, you could have. But because you're trying to use complex numbers to give you a real solution, it wouldn't work.
Right. That's why
I know, I see all those internet videos too, and I'm looking like, oh, they're doing this wrong and that wrong and that wrong, and oh, it all works out at the end. No, it doesn't. So.
Yeah, that's why I said like false proof, because it doesn't actually work.
Yeah. Yeah, I quit watching those videos. I was getting too mad. All right. Any other questions on this one? All right. So let's say if we wanted to multiply square root of negative 2 times square root of negative 20. Zoom in a little bit. Okay, so just like before, our square root of negative 2 times square root of negative 20, bring that over a little more, we can just make that I square root of 2 times I times square root of 20. So everything's just multiplied. Okay, so we kind of move things around. You don't have to do that part if you want to, but you can have square root of 2 times square root of 20 times I, where these two, remember, you can just put those right under 1, or you can simplify the 20 first. Okay, so you have, actually, I think I'll do the 20 first since it's a smaller number, instead of making that square root of 40 and simplifying it. Actually, that will probably work a little better. Okay, so square root of 2 times 20. I'll do it that way. And you have I times I, which is I squared. Okay, so you have square root of 2 times 20, which is 40, times your I squared, which is negative 1. And remember to put that here. That I squared equals negative 1. That's just times negative 1. Okay. Now 40 is just 4 times 10. So I'll work that out on the side here. So square root of 40. Remember, that's equals square root of 4 times square root of 10. Or just 2 square root of 10. So we can just make that negative 1 times 2 square root of 10, or just negative 2 square root of 10. Okay. So like I said, you could have simplified it here and made it 4 times 5. And then the 4 came out and you have square root of 2 times square root of 5, and then just combine those. So it's a couple of ways you could have done this one. All right, but they all should have led right to the same answer. Okay, any questions on this one? All right, I'll leave that up for a few seconds. so let's say, for example, if you want to multiply, say for problem A, if you add 6 times 2 plus 9i, and for problem B, say negative 5i times 4 minus 8i. Okay. So with that one, you just distribute just like you would any other multiplication problem. Okay, so for A, if you have 6 times 2 plus 9i, just go ahead and distribute it. So you have 6 times 2, which is just 12. And you have 6 times 9, which is 54. So you have plus 54i. Now with that one, that's as far as you have to go. But if you have one like B, so it's negative 5i times 4 minus 8i, and you distribute that one, then that would give you negative 5i times 4, which is negative 20. Nope, negative 20i, sorry about that. And then for this one, you have negative 5i times negative 8i, which would be positive 40i squared. Okay, so you do that just the same way you would if you had negative 5x minus 8x. That would be just negative 40x squared. But the only difference is that I squared equals negative 1. If you had just x squared, you'd stop right there. But with the I squared, you have to remember that equals an actual value. Okay? So that's negative 20i plus 40 times negative 1. Okay, so that's going to equal negative 20i minus 40, but most of them will want it in that a plus bi form, so you just switch them around. So that's negative 40 minus 20i. That's that a plus bi form. All right, so any questions there? So really you're doing, like I said, just the exact same thing if you were dealing with variables. Just when that I squared pops up, you'd have to remember that it equals a negative 1. All right, leave that up for a few more seconds. Okay, let's do writing. Looks like everyone's done writing. Okay, so let's say, for example, we wanted to multiply, say, negative 4 plus 2i and 2 plus I. And for this one, we'll just do the good old-fashioned FOIL method. Okay, so our first, let me just rewrite it. Negative 4 plus 2i, 2 plus I. So our first will give us negative 8. Negative 4 times 2 is negative 8. Our outer, negative 4 times I, is negative 4i. Our inner is 2i times 2, which is plus 4i. And our last is 2i times I, which is 2i squared. Okay, so these two middle ones cancel each other out. Negative 4i plus 4i is just 0. You also remember that I squared equals negative 1. So you have negative 8 plus 2 times negative 1. Okay, so you have negative 8 minus 2 is negative 10. But in most cases, they will want that a plus bi form. So you're going to make that 0, negative 10 plus 0i. Sorry about that. So negative 10 plus 0i. Remember, that's that a plus bi form. Okay, so even when you're done, you still have to remember if it has it right in the instructions, put it in complex form, that 0 or a plus bi. Okay, any questions on that one? All right. Okay, so let's say, for example, you wanted to multiply, say for problem A, say 2 plus 3i times 3 minus 2i. And for problem B, I'll say problem B for another. Yeah, I'll do it now. Let's say if we wanted to multiply square root of negative 80 times square root of negative 80. Okay, and we wanted to write in a plus bi form. Okay, so for problem A, we do just like we did before, just do our FOIL method. Okay, so our first, 2 times 3 is 6. 2 times negative 2i is negative 4i. 3 times 3 is 9, so that would give us 9i. 3 times negative 2 is negative 6, so it would be negative 6i squared. Okay, so just like before, we want to remember that I squared equals negative 1. Okay, so that would give us 6, and we can go ahead and combine those two. So negative 4 plus 9 is 5, so that gives us plus 5i minus 6 times negative 1. Okay, so we end up with 6 plus 5i minus 6 times negative 1 is negative 6, so that's just plus 6, or 12 plus 5i. Okay. Now for problem B, you have square root of negative 80 times square root of negative 80. Bring that up a little. That's just going to be I times square root of 80 times I times square root of 80. Okay, so it gives you, well, square root of 80 times square root of 80. Square root of 80 times 80 times I squared. Okay. Now really with this one, if you wanted to, just to make it a little easier, you can make a square root of 80 squared. And just like before, you know that I squared equals -1. So you have square root of 80 squared times -1. Okay, so when you have a squared and a square root, they kind of cancel each other out. So you're left with 80 times -1, which is just -80. Okay, any questions on this one? Yes. Oh, I'm glad you caught that. It's really easy to forget. Okay, so you have -80 plus 0i. I know I sat there and told you not to forget it, and I turned around and forgot it. Which shows you just how easy it is to do. All right, so any other questions on this one? And this is our a plus bi. Oh, let me move this over a little bit. Okay. Clean that up just a bit. Okay, so that's our a plus bi form. And this is our a plus bi. All right, leave that up for a few more seconds. Looks like everyone's done writing. Oh. Okay, so now we're going to look at dividing complex numbers. Okay, now if you remember, when we did our dividing of radical numbers, if you had 2 plus square root of 3, you know that 2 minus square root of 3 means they are conjugates of each other. So your sign changed. It's the same thing with complex numbers. In general, a plus bi and a minus bi are what they call complex conjugates. Okay? It's just a fancy way of saying they changed the sign. Oh, bless you. Okay, so if you have 7 plus 4i, then that means that 7 minus 4i is its conjugate. So they're complex conjugates. Or what if you have 5 plus I? And we know that 5 minus I is its conjugate, or complex conjugates. Or what if you just had, say, negative 6i? If you think of it this way, negative 6i is just 0 minus 6i. So that means 0 minus 6i and 0 plus 6i are complex conjugates, which means 6i is its conjugate. So minus 6i and 0 plus 6i are complex conjugates. Okay, which means that negative 6i and 6i. So the sign only changes for the complex value. I mean, not the complex, the imaginary value. All right. So this is kind of one of those rules you don't have to remember because it kind of works itself out, but it's similar to the difference of squares. Multiplying a complex number. Uh-oh. So if we have a plus bi and its complex conjugate, which is a minus bi, they actually give you a real number. So is the real number a squared plus b squared? Okay. Now, with the difference of squares applying to real numbers, it would have been a squared minus b squared. Well, the complex numbers is a squared plus b squared. All right, so let's give an example of that one. Leave that up for a few more seconds. Oh, it's going to shut off in a minute, so I might